So we are both from Pretty Easy Privacy, and Pretty Easy Privacy is somewhat of a easier version of Pretty Good Privacy, PGP. So first of all, I would like to know who of you is using who knows what PGP is? GPG, PGP. Okay, who's using it? Okay, who's using it daily? Okay, that's already much less. And who was trying to use it in a group for somewhat of an action and gave up on the way? No one. One. Okay. Who was actually trying to use it for a group and didn't give up and it worked? No one. All right. Okay. So now it's the two of us. Later, Walter will be joining the stage. This is Nana. Nana is working on sustainable transformation since long time. She has studied philosophy, mathematics, and psychology, and holds a PhD in applied economics. She's also working with self-organized movements and brings academic expertise in complex systems. And she's working with the PEP Foundation as well as with the research group for ethical and ecological rating at the Goethe University in Frankfurt.
Yeah, I can say some words to SWA. SWA plays an active role in the oldest hacker association of the world, the Chaos Computer Club in Berlin or in Germany. I mean, we spread over Germany, but she's particularly active in Berlin. She does conference since a long time, is a board member of this Chaos Computer Club now, and also has co-founded and mentored various hack spaces. So she also has a very long track record in building infrastructures for these kinds of activism work. In India, she's active for a long time to establish the Hill Hacks, which is a large conference there as well, and Hack Beach which is also, it's a conference? Oh, it's a conference.
Both of them are hacker camps, like the conference.
Then she had multiple crypto parties and is also a member of the crypto party admin team based in Berlin. And today she continues working on the goal to have privacy by default. We are both engaged for mass encryption. We will tell you more about this later. At the PEP Foundation, where we are working together. She holds a diploma or has graduated in cultural anthropology, philosophy and computer science in Munich. And here I have some words about SWA which I really liked, which is an event guru and crypto missionary. So this is really what she is.
Great. We also have some words on the Cyberpunk Manifesto. So as Nana already mentioned, we're trying to implement mass encryption as a counterpart for mass surveillance. This is more like long-term plan. But the Cyberpunk Manifesto is something where the whole group is also standing on. I don't know if you want to read out loud.
I decided to not read out the quotes as such, but I'd like to give an overview. There are three rough ideas that are basic for this manifesto, which is first accessibility or common good. Privacy should be a common good and it should be accessible for all. And the second is, can I see that?
Oh, sorry.
We need to have anonymity through encryption. So encryption is the technology or the way to get privacy. And in the end, we have to do it ourselves. If we want to have privacy, we have to make it, because we cannot expect that it, falls from the sky, or that the powerful entities on this planet will give it to us. So, and these are three key points outlined in the Cyberpunk Manifesto, which is from '93. And as well, the PEP Foundation as such, or PEP as an organization as such, as well as we as persons, stand in the tradition of this manifesto. Therefore, we would like to start with that as a notion. So now I will start to introduce pretty easy privacy as a concept and also as what we do with our organization. So perhaps kann ich das etwas größer machen? Okay. Ja, die Slides.
Das ist das da. Ganz vergessen.
Okay. So we are in the process of having our RFC consultation process in the IETF. So I will tell you later what this is exactly. And this internet draft describes how PEP is done technically. And here it starts with what it is. So it is building on already available security formats and message transports. That means we don't make own encryption. Pretty easy privacy describes protocols to automatize operations, key management, key discovery, private key handling. This means we automatize those steps that used to have been done by the user in terms of installation and configuration. And that have been seen to be barriers to deployment of end-to-end secure impersonal messaging. So this is the key point, that we want to make the usability as easy as possible, which is, to say it frankly, it's not been seen anymore for the user. So this is the idea. We move it into the background, but it's still there. It's state-of-the-art encryption. Yeah, so PEP is a cross-platform abstraction to easily use existing crypto tools. This is what I said. We use GNU-PG. We implemented it in the core code, but it does have an own core software which does this protocol around the encryption itself. PEP's long-term goal is to actually encrypt all digital written communication. As for now, we are starting with email, so there are releases out for the email already, but we want to also use it for OTR and messaging and all kinds of stuff. So we really try to have a long-term goal. We want PEP to encrypt automatically whenever and with whatever most privacy enhancing. So the PEP software chooses the encryption way that is the most privacy enhancing. Crypto standard is available, and the slogan privacy by default means that we try to have it installed and used by default, so the user doesn't have to do any opt-in or opt-out. It doesn't have to do any installation. The installer just installs. It doesn't ask questions. This is so the result is that we get a user experience similar to Signal or WhatsApp if somebody uses WhatsApp. So it is somehow encrypted, but the encryption happens in the background and you don't have to do it yourself. So we're taking away those needs from the users and still enable everybody to have state-of-the-art encryption. As said, PEP is, of course, it's a startup, so we try to establish our organization, but we do have a political activism idea behind it in terms of that we want to roll out mass encryption to optimize the costs of mass surveillance. Like, we want to make it as expensive as possible so that the authorities it's more difficult for them to get all the emails, for instance. Also, I won't go into details on the developer side, but we also have the idea that other app developers use it, so there are very simple APIs for different programming languages. So if app developers want to use patent technology, they can just use it very, very easily, and they also don't have to hassle with the crypto behind it. And of course, the user won't have to as well. And we just started the PEP organization, so there are several entities. We'll come back to that later. But the whole thing started in 2012, and the PEP Foundation, for which we are here, it was founded in 2015, and we're effectively working since last year. Then, as already said, here you can see like an overview on the key point and the features we provide. It automatically encrypts. It encrypts the subject line, for instance, already, so it moves it into the body. no key management is needed. No key server, no other central infrastructure. It's peer-to-peer. It's end-to-end, and we use trust words instead of fingerprints. If you know PGP, you are familiar with these fingerprints, these long lines of numbers, and we have a mapping towards natural language words, which means that it's much more easy to compare them. There is an opt-in for a passphrase of keys. You can also use it without that. And the header is encrypted and obfuscated. And we do have an innovative solution for key synchronization between devices. We'll also come back to that later. It's just here. It's just an overview so that you see what we provide. And as I said, we have this activism idea. We were really trying to do everything right in terms of that we try to focus on what's politically important and focus on what's technologically important to get privacy deployed within the normal society, to enable the normal citizen to use it, to enable activists to use it, to enable dissidents or other people that are active with really important work in the jobs they're doing to have encryption and not being forced to learn all this technical stuff if they want to save time for the job they're actually doing. And of course, it's all free software, and we have a very close eye on audits. The core technology has been audited very sharply already, and the idea is that every proper release will be audited as well. So we try to make it as transparent as possible and as secure, of course, as possible. And another thing is that it's important for us is it's also that we try to have it as compatible as possible. So it can be used on multiple platforms. It can be used with, or it uses multiple crypto technologies. As I already said, it's good for multiple programming languages. And in the long run, we want to provide solutions for multiple message transport systems as well. So we really try to just open the doors to easy encryption by the PEP solution so that these things can be spreaded much more easily. One point I would like to stress here, because it's one of our main things in the middle run. So as I said, some releases are out already for email. And the next thing we're really working hard on that is that we have an idea how to encrypt metadata. This is who communicates with whom, when, and from where. So as for now, there is no technical solution to protect the metadata as well, meaning that even if you encrypt your email bodies, like the content, the whole social graph can be intercepted, which is important if you work in sensitive environments where the people would like to know who you're talking to. And there is a long-term cooperation with a project called GNUnet, and GNUnet provides a way to, on a peer-to-peer open source basis, protect metadata. And now the next step will be that we work on the first tentative steps to integrate those two projects. So it could well be that PEP offers a way to protect metadata for the first time within the next several years, I would say. In the end, our slogan is privacy by default. In terms of that, as I said, the installer just installs, it doesn't ask any question, it's quick. And it does for the user, what the user would want to do if it was a professional user who really knew how to use PGP correctly. So if you know how to use it correctly, everything is fine. You can also just stick to that. But if you don't know, you can also use PEP, and it provides you with the same service. Yeah. So this is it again. It's, so to say, a little hacker inside of your machine that does it for you, and you can be sure that it does it all right. And it's also much more easier to invite other people to use encryption as well, because it's easy for them then as well. So that's the idea. Now I said we have a RFC, and I said it's a protocol that automatized the steps taught to users as at crypto parties. So the question is,
yeah, who knows what a protocol means in that context? Okay, just a few. Who knows what RFC means in that context? Okay, the same few. Okay, so we'll be explaining that a bit more. But the idea is just to go back to this one. If you see, it's this little hacker inside. So for everyone who doesn't know about the protocols, can still imagine that we, in a daily base, when we communicate to each other, each time we decide what kind of communication we use. Like I'm talking to someone, I'm leaving the house, and I say, okay, now I'm switching on mobile, what app do you have? Let's switch there. So every time I'm deciding in my head what communication method I'm going to use, but this is what we can do because we are into this, but we cannot expect this from everyone in the world. So we're trying to put this into a set of rules. We'll be coming back to this later, what a protocol actually means, and but it's kind of a set of rules how to communicate to each other. And to have such a protocol, you need this thing called RFC. And to explain both of it, we'll be stepping a huge step back into the late 50s. And now I'm making a quick run through where the internet came from, so that we're all somewhat on the same base when we're talking about the ideas, especially GNU-net, what's the plan to change. So when we wrote the first email to Kirsten and Edri, the other guys from Edri, and they were asking what would be the main outcome of this session. We were like, we want to give back hope to the hopelesses. So the idea is to explain you where the internet comes from and where is the underlying problem of all, and where might be the solutions, at least the solution we're proposing, which is not something, okay, PEP you can use right ahead, but this only makes your email encrypted. This is only, you only work on a symptom here, but it's not really curing from the roots. But the other approach of really changing the internet infrastructure is going to change a lot, and it's going to make some of our problems just disappear. But to understand that, you somewhat need to know where the internet comes from. So we decided to start with the late 50s when Sputnik was put into space by the Russians. So there is no actual beginning point. People would set the beginning at various places, so we just decided to put the Cold War as the starting point, because the USA had to respond to that Sputnik shock. So they founded the Advanced Research Project Agency, which was the ARPA, renamed in '72 into the DARPA, the Defense Advanced Research Project Agency. The special thing of that task force was that they haven't had any particular order. It was just like, okay, do something better than the Russians have just done. There is nothing like all those legends that they actually created the internet to be safe from wars and all this. This all just came later. The original idea was just, okay, now they have done something awesome, now we give you money to do something awesome as well. So they got lots of money, and especially they got autonomy, which is very special in the defense context, in the military context. Usually the researchers are somewhere hidden in their cellars, and they're not allowed to publish, they're not allowed to go to conferences. But here it was different. Those guys were publishing things. So this is the first publication in '61, information flow in large communication networks. So this guy, Kleinrock, had the idea of packet switching networks. So that was a PhD thesis. He just wrote it. Some of you might think now, okay, packet switching, what's this about? You might have seen those things in old movies where when you had to make a call, you actually say, hello, can I get, in German we say ein Amt. I don't know what it was in English though. And then the lady was saying, okay, I connect you, and then they were actually connecting those lines. So this way of communication was actually till the 70s. It was still there in the 60s, 70s, that when you were taking a call, that you actually got connected, your telephone got connected to the telephone you wanted to call to in one line. So now this guy Kleinrock had the idea of packet switching, which means that you are not connected in one line anymore, but the whole communication gets split into packets, and those packets get sent somewhere along the lines that are existing, and at the end they are put together again to get again a voice message or whatever it was. Back then they weren't experimenting with voice messages though, but with like text and all this. So right ahead in 62, another guy, Licklider, wrote a series of memos discussing the intergalactic computer network, where he was imagining a lot of computers connected to each other. At this time, time sharing already existed, which was a multi-user system for mainframe systems where lots of users could use the same computer at like different times, but also remotely. So the idea of being connected to a computer from a remote location, like not sitting at the computer, was already there. So it continued with some publications. Then in 67 there was a big conference, and 69 the first 4 computers are connected. So this is often the birth of the internet. This was the ARPA network, which looked like this on the map, and it grown really fast in those years. And the speciality here, what I would like to have you remember, is that at the beginning, those inventors are both. They're users and developers at the same time, as well as the technology is both. It's the object of research and it's the media for publication. This was like a very new thing. Usually, you were either a user or you are a developer. This is like nowadays. And usually you were researching something and you were publishing somewhere else because there wasn't anything before. So that media for publication, that like internet that started to slowly exist, gave the opportunity to just publish any thoughts and any ideas you had, which leads us to the RFCs, which means request for comments. This is from the very beginning till today the way how decisions are made, what's the technology standards of the internet. So this is where technical and organizational issues are discussed. So someone makes a request for comments, others comment on it, and they keep that name, and they often got standards. So if someone has an idea and says, okay, let's do it like that, and everyone's like, oh, this is great, let's do it like that, then just everyone's doing it. This is like if you have a web server and you say, oh, I want to like make a different technology and I use my web server in a different way, then no one is able to use it because no one agreed on, okay, this is a technology we could use. Everyone agreed on using HTTP as a technology which you have in front of your web URL, and so every web browser is able to read what every web server is delivering. So today we have around 8,500 RFC, and I just picked some examples here. Very early one is FTP, the file transfer protocol. I come to this later when it actually got invented. Then there is DNS, the domain name system, which transports IP addresses to names. Then Usenet IP addresses, Gopher, which was a similar system than the web. IRC, then the assigned numbers for also domain systems. But then at the bottom I also picked out 3 different ones. One is ethics and the internet. So this already has been discussed already quite early, see the number. Then, sure, recursiveness is something in that technology you find everywhere. Instructions how to write an RFC. So there's an RFC on how to write an RFC. And then also iCalendar and everything that is established nowadays also gets an RFC. Like PEP also now started to draft an RFC. So nowadays there's a two-step system. Before you give out the RFC, you first make a draft, because otherwise it would have gotten too much. Okay, so this internet was growing here. Some pictures with how it looked like then, end of the 70s. And here's a list of stuff that happened in the 70s. So especially 97, the Network Control Protocol, the NCP, was ready and usable. This was, the protocol on how two computers can talk to each other. So there were applications developed. There was Telnet to connect computers. There was FTP to connect information, and there was email to connect people. Interestingly, email already had like 75% of the whole network usage was email. So people were always keen on using it for their purposes. Then 73, also some vendors, PC vendors, were trying to implement their own net, which fortunately didn't work out. So the net always stayed free and open. 75 is an interesting cultural point where there was a first non-tech mailing list, Science Fiction Lovers, which was kind of a very huge discussion. And then TCP/IP came, but we'll come to this protocol thing later. 79, there was the first documented use of a smiley, tongue-in-cheek, it looked like that. And 79, the Usenet and BBS systems started, which was kind of the ARPANET for the people. Remember, the ARPANET was still for military use only, and then the scientists also took it over, but then it was also there for the people. Here's an overview of the 80s. Sure, Chaos Computer Club was founded, I need to mention that. Then the Milnet splits from the ARPANET. So the military crowd figured, okay, there are way too many people running around in our network, so let's just split it. Most of the nets of the nodes went to the Milnet. The ARPANET was then pretty small, but then you see at the bottom that the National Science Foundation was also founded a network, like the NSFNet, which took over being the backbone. And there was the transition from NCP to TCP/IP. So everyone had to make that transition at the very same second, which was very funny. So that's why they all got those buttons. I survived. Cyberspace appeared for the first time, and the domain name system came out. Then 1990, the ARPANET is switched off. But the users don't reckon because of this National Science Foundation backbone. And, very important here, Tim Berners-Lee writes an application which is called the World Wide Web, which was just like yet another application. You know all the World Wide Web nowadays. This is what most of the people do when they say they go online, they go to the internet, they actually go to the web. They're not using the internet, they're only using the web. Which is then using the internet, but there's much more. You see, this is now already 20 years of internet, and there hasn't been any web. So now a lot of browsers got developed, but no editors, which wasn't the intention Tim Berners-Lee had. He wanted to have editor equals browser. So for him, the whole web he was proposing looked like Wikipedia, where everyone could click the edit button and do something different with it. So now we're running into a scene where users are consumers. It's not that users are developers anymore. It's not that, users are participating. Now in the 90s, they're all just consumers. And then it happens in the years after that the Cyberpunk Manifesto, which we had before, and the Declaration of Independence of Cyberspace got written, and similar texts along those lines. Because now, as the users were consumers, activists figured, okay, something's going wrong. If you don't know the Declaration of Independence of Cyberspace, you should definitely check it out. I'm not going to read it out loud. And then some of you might remember in the 90s, more and more attention got onto the web. Everything gets famous, we all got modems at home, and a lot of new companies gone public. And towards the end of the century, they were overvaluated by the rising demand, and the so-called dot-com bubble burst, resulting in a stock market crash. Some of you might have been there. And now the scene is very different. All the money is gone, all the interest is gone, and now stuff like this happens. Wikipedia, blogs appear, Freifunk is something which was founded in 2001, which is an initiative where people set up Wi-Fi antennas on houses to make own connections to each other, to just have like an internet, like an own network, not based on the actual internet. So lots of projects like this happened then in the early 2000s. Then 2004, the Web 2.0 was used for the first time, which goes back to the original idea of many-to-many. The users are at least developing content again. 2005, the National Science Foundation Internet backbone is switched off, and the internet is now completely provided by private networks and commercial internet service providers. This is the state till we are right now still, which is a huge problem for net neutrality. I guess everyone in this crowd should be aware about the problem of net neutrality, is it? Who is not? Yes. Okay. This is how it started. And this is still the problem that the internet is now fully in commercial hands. The commercial side came back. Facebook and Twitter got founded in 2006, but also WikiLeaks. And here's a rough run of the latest news. 2010, I got this number of 95% of all emails are spam. Then IPv4 addresses are gone out. Who knows about IPv4, IPv6? Okay, quite a few. Then 2012, some anthropologists were publishing an article where they said with 68 Facebook likes, you can predict people's skin color by 95% probability. You can predict if they're homosexual by 88% probability. You can check if they're Democrat or Republican. It's been used for votings mainly by 85%. You can check on their intelligence, their religion, if they're taking drugs, and if the parents of a person stayed together or not till the person turned 21 years. And this only with 68 Facebook likes. And this has been published in 2012, which is now 5 years back. If you have 10 Facebook likes, you can predict a person, or you know a person like a working colleague. If you have 70, it's like a friend. If you have 150, it's like your parents. And if you have 300 Facebook likes, you can predict as good as your partner. And if you have more, you can predict even better than yourself. And now, I mean, look, I'm not using Facebook, but look at the crowd out there. 300 Facebook likes you get from a person within 30 days. 2013, Edward Snowden was publishing his stuff, and now we want to ask the question, is privacy not only political, but also technological problem? I don't know if anyone has an opinion on that. Okay, yeah?
It's both.
It's both,
yes.
yes, exactly. So there is a base of a technological problem which we are trying to address, and which lots of hackers are trying to address. And there is a political problem which I guess all you are trying to address, and also lots of hackers are trying to address, and also Edward Snowden did a good job on that part. But also he did a good job on showing us the technology problem. And this is the part where we want to go into.
I'd like to add one sentence.
Mm-hmm.
I mean, the technological problem as such is there, and Sva will tell you something about it, but it's probably worsened, or it is worsened by the technologies that are out there to break privacy. So it's enhanced in a technological sense as well. So one has to think about that as well. So it's not only like solving bugs, but it's also like solving the problems to do bugging in terms of privacy.
Exactly. So you have heard in this history that lots of stuff got invented in the 70s, and I'm telling you, we're using that stuff till today, which finally brings us to this protocol thing, which I was mentioning so often. So there are communication protocols. There are three types of them we want to talk about to explain. There is a human social protocol, there are software protocols, and there are network protocols. Anyone wants to explain some of them, or has an idea about one of them? So the human social protocol is something like, okay, how do we communicate with each other? We have to agree on a language. Wenn ich jetzt Deutsch spreche, wird mich kaum mehr jemand verstehen. So we have to agree on a language, because otherwise, like, you're not able to understand. Also, we might have to agree on grammar to understand each other. And then also, if I'm going to church, I might have to put on my jacket again. Or in some churches, I might even have to follow the protocol of covering my head, right? So this is a social protocol where we define how to interact with each other, to communicate with each other. So the same works for network protocols, where there is defined how computers talk to each other. And there are software protocols that define how software should behave. Like PEP is trying to implement a software protocol on how email clients should behave. As in, Nana said that key management is not needed anymore. But everyone who's into GPG would be wondering, okay, but how do you GPG without any key management? That's because we're telling the email clients how to handle the keys. So for example, every email shall attach the key, unless there's already encrypted communication and the key has already been exchanged. But by default, you just attach the key, so you already have one part of the key management solved. And this is what we can write into a software protocol. And then we have network protocols, which is, the rules of communication. When computers communicate with each other, there needs to be a common set of rules. A set of rules for data exchange, an agreement that defines how data is transferred between two or more parties. And it defines the syntax, semantics, and the synchronizations of communication. And on the lowest layer you can imagine, a protocol defines how a link hardware should behave. Like, you have a wire and it's going into a box, and that box is making Wi-Fi. So here a protocol comes into place that tells, okay, how to transport this data into, like, from the format of the wire into the format of the Wi-Fi. Or you have a copper wire and it goes into a fiber wire or something. Which protocols do you know about? Any
we actually
examples?
tried to make it very interactive.
Yeah, we were told to have it participative, but you guys are still in the early morning mode. That's okay.
Where's the chalk?
We have chalk. That's even nicer. Okay.
Any protocols you know about?
Yay! HTTP. This one's the name. Yeah. Okay, FTP. SMTP. SSH. FTCIP?
Sorry.
No problem.
TLS.
Yes. Any more examples? There's even something like, we have a Bitcoin protocol.
XMPP. Signal protocol.
Yeah, that's called axolotl. Ah, no, the signal protocol is not axolotl, is the crypto thing, right? Yeah. Okay, any more?
IRC.
It's not a protocol. I don't know what the protocol of IRC is called actually. Okay, but I think that's already fine. Here we have the OSI model. Who has heard about the OSI model? Or who actually knows about it? Okay, quite a few have heard about it. That's great. So the OSI model is just a model used in science. This is like, lots of people would be saying this has nothing to do with reality, but it's still, as usual in science, it's good to imagine how stuff works, to put it into a model which you can work with, where you have layers, where you have pieces. So
it's good to actually also understand that the internet is on the bottom something physical, which many people don't really realize. It goes into the earth at some point.
Yeah. So let's start at the physical layer. So this is layer 1. It's called the physical layer, and there is Ethernet. So this is now example protocols. Ethernet, USB would be a protocol as well. Bluetooth, and this IE 802.11. This is a Wi-Fi standard as far as I know. So this is where it is defined how stuff goes from one wire to the other. Then we have the data link layer, which is the Ethernet layer, where the stuff from the wires actually gets translated into data, let's say. Then this data goes to the next layer, where it gets transported through the network. So now we have protocols that define a layer, and we have protocols how to communicate between the layers, right? Then we have the transport layer, then we have the session layer, the presentation layer, which is, for example, your operating system, and the application layer, which is your actual application. So now let's see what we had. FTP is application, SMTP is application, this is email protocol. HTTP is application, SSH is application or presentation? Somewhere. Bitcoin protocol is application, TCP IP, oops, that's a C.
Yeah.
TCP IP is, we have it here, TCP and IP. What else did we have? XMPP is application, Signal Protocol is application, TLS is a presentation. So, except for TCP IP, we were now only on this layer with everything you told us. And I guess even if we had like the full wall full of words, full of abbreviations, still we would have had mainly or maybe even only application and presentation layer protocols. So this is the part where your presence in the internet is like where you are in the application and on the presentation layer, which is operating system and applications. I leave this out, which is just a bit more of an explanation of this model. Because we only have 20 minutes left. What do you use in the network? So you make emails, I guess, everyone. You're using web, otherwise you wouldn't have found here. You would be using maps. You'd be using file sharing, maybe. You'd be using entertainment, like not only on the web, but also maybe this like TV stuff. You'd be using Tor. Who's using Tor? Two less. What else do you use? Online, what do you do online? Instant messaging, lots of messaging, right? What do we have?
You probably buy things and do online banking, maybe.
True. Who doesn't do any online banking? Who doesn't buy anything in the internet? Okay. With hackers, it might have been more. What else
You
did
might
you
look
notice?
for a job or something. So there's just like the more intense the internet gets, the more data you have to use to get what you want. It's just natural, but it's also, well, you know about that.
Yeah. You also might use voice over IP to talk to each other. So this is stuff all that you use, which you use in the current internet, which has a problem. That the network generally learns too much. This IP protocol, which I told was done in '78, generally learns too much. It leaks like information like crazy. In the header, you have the from, you have the where it goes, which port it goes to. Then you have insecure defaults and rather high complexity for management. You have lots of centralized components, and then you have even administrators, which might be malicious, they might be just incompetent, and even if they're nice guys and they're doing a great job, they are a target. So the people can say, okay, you're the administrator, you can get all the data. So those flaws are often misused. So that's like when we talked about the stuff we're using online, again, most of it is on this application layer, and here is one other layer thing where we made it a bit more concrete. Again, the physical layer, Ethernet, then the transport, and the application on top. So now, just a brief insight. This is what GNUnet has proposed. There's about to come a new release, and it's not for use yet, but it's for geeky testing. So there is the physical layer, we just use any kind of existing protocol, whatever needs to be there. Then there's an off-the-record encryption right ahead, and some distributed hash table routing, then the transport layer, then a name system, the GNU name system, and the applications, which is at the moment a voice over IP application, file sharing application, some kind of a social networking thingy, and yeah, PEP for email, Thaler for payments, but it's all in a experimental state. So this is something we hope to have in a couple of years for everyone out there.
But if everything goes right, we will start this year by emulating GNUnet to, as a first step, test the scalability. So as far GNUnet has been an academic project, or it emerged from an activism and academic background, and the code is there and it functions in what they do so far, but it hasn't been deployed so far. So we first start to test scalability if the GNUnet is able to handle up to 1 million users, and this project is about to start. I hope, if everything goes right, I don't know, second quarter of this year, and the PEP Foundation will run it.
And at this point of time, it's really important that everyone who's a little bit more into just tries it. Don't install the release from 2014, but take the one from the Git repository, please. And there will be hopefully like proper release soon. Also, don't take the packages in Debian or something, because they're also the release from 2014. And then test it and find all the bugs. So it won't run most probably, but it's and there's an IRC channel, #GNUnet on Freenode, where you can get all support. So here we have on every layer, we have somewhat of an encryption, of an obfuscation, of a decentralization implemented. And now, just briefly, what is crypto? Because I had the feeling that lots, it's like non-technical crowd. It's a mathematical way to make the data only readable for the one sending it and the one receiving it, which is then end-to-end encryption. When you encrypt, you get a code or a key. So here is a simple encoding with a simple key. I guess everyone can see what's the key of this encryption, right? The key is just turn every word backwards. So this is very easy to see. Maybe as childs you had some like secret languages where you exchanging some digits in the alphabet. So this is like simple encoding, and then the key is, okay, change everything like 3 letters into the alphabet or something. So nowadays we have software which helps. How to choose software. If it's old, it's good. Check where it comes from. Check if it got broken in the meanwhile, and check if it's open source. If not, don't use it. So PGP, what we've been talking about now often, is pretty old, since 2091, and it's open source. It's developed by a private person with a cause. This guy was actually an activist in nuclear plants activism, like anti-nuclear plants activism. And so he said, okay, we need something for encryption, so he started PGP, and it's still unbroken. Basic principles are confidentiality, integrity, and authentication. And now we have another 10 minutes or 15, because Walter said we can take some of his time.
It might take 5 minutes.
Yeah.
Yeah, I would start this last part with summarizing low and high hanging fruits. So we had the technological side of the privacy problem in terms of the structure of the internet, which offers way to intercept data. GNU tries to solve that on a peer-to-peer level. And then the other side, which I would say includes higher and lower hanging fruits, is the encryption itself. Can be good or bad, and can be easy or not easy to use. So this just is a very rough catchword to where we are now. Now the question is how should encryption be? Are there important features? Of course, if you try to look good encryption, it tells you a lot about code. It should be not too long. It should be as short as possible, but as long as necessary, and stuff like that. It shouldn't be broken if just 1 bit changes or stuff like that. We are focusing on we have a bit of different focus here, and generally, of course, it should include flawless code and respectively correct mathematics. So I won't go into details on that end. But of course, as I said, the PEP engine has been audited very closely. If you're interested in the audits, you can find it online. PEP Foundation docs. The following features outline more important qualities that proper encryption should have, and all of them are realized in PEP solutions. So we don't want to advertise too much, but I wanted to go a bit more into detail what PEP actually provides. First of all, of course, it's open source. Why is open source important? Because it makes sure that there are no backdoors installed, because other people can see the code, they can reread it and verify it, and this makes sure that there are no hidden backdoors, because it's just open and the others will look at it. Decentralization is an important feature. Why is this so? Because it avoids interceptions through third parties, also known as man-in-the-middle attacks. If you don't want the admin to be able to read your private messages, as recently came out in the case of Twitter, where people are like, what? The admin can read my private messages. How can this be? Of course, in a technical sense, it's just nobody would really wonder. But of course, the user was really surprised. In a societal sense, in terms of what kind of societies we want, decentralization avoid monopolies, and also it enables innovation, because it makes systems diverse. And of course, central databases also can get lost, which is a huge problem, because then your data is just gone. And you should all have in your mind that there is no cloud, it's just the computers of other people. So, as I said, the internet is physical. It's physical on the other end because they're humans, and it's physical in terms of the hardware. Then what does that decentralization mean in terms of what the encryption does? it can mean end-to-end, which means that endpoint-to-endpoint encryption is in place. And this, in other words, says just you and me have the key and no one else can see it. It can also mean peer-to-peer. What does that mean? This is node-to-node communication. And in other words, this means that nodes take over the function of being clients and servers towards each other. So the network structure itself is level out. There are no hierarchies. And in other words, it means just you and me have the media line or connection and no one else can listen. Then another important feature is verifiability, trust words. And here I come back to what I said in the beginning. So you know these lines of numbers and letters that you can read to each other on the phone to verify your key. What PEP did is mapping them on the alphabet of mother tongue languages. So we already have different languages installed, so it's, I think, Turkish, English, a whole list of them. And then you can just say, so my fingerprint is battery or staple, for instance. And the other person say, yeah, mine is this, and I can see it's the same. So it makes it much more easy. And the handling of fingerprints gets intuitive. Another key feature that we have now is key synchronization. Why do we need that? Because to actually use encryption on encrypted communication on the internet on a day-to-day basis, you want to be able to encrypt your email, to read your encrypted emails on more than one device. Nowadays we all have smartphones, we have tablets, we have different computers maybe. And the PEP keysync solution is a real innovation because it for the first time provides a secure and decentralized, it's decentralized as well, decentralized synchronizations of keys between different devices. I don't know, I cannot promise any dates, but the keysync is also sort of about to be released. As I said, we're at different fronts in a phase where we work on different releases, and they are about to come out this year or so. I hope, maybe. This shows you how the key sync in general functions. So the two devices talk to each other and they compare the key, they do the handshake automatically, and it's more or less the same process as if you do the key exchange with another user. It's just that the devices compare their keys. Then we have the question of compatibility. Why is this important? Because we want to have high usability, we want to have it spread, and this means that we don't want to have walled garden solution, so that you only have to use a specific app and then the other person has to have the same app. So the idea of PEP is that it really enables communication between different platforms. I said that already: program language, crypto technologies, massive transfers and devices. So this was it about the features. Of course, we are here the whole day, so talk to us. Let us know if you have questions, if you want to cooperate, whatever. We are engaged in the community as well. The PEP project as such is spread into different entities. There are commercial entities selling end-user apps because we really want to have it deployed far in the society. So we do work together with companies as well, and they have to buy it. But the software is open and free for every normal citizen. And the PEP Foundation, which is the part of the project we are working for, it's a separate entity. We're non-profit, we're tax-free, based in Switzerland, and we own PEP's core code, meaning these protocols that automatize these processes. And this gives us security in terms of independent code, and we cannot be sold out or bought, because the PEP Foundation only gives licenses to anybody who wants to use PEP software. And what we do as a foundation is we develop these core bases, we support other FOSS projects, we finance and coordinate code audits, and we're engaged in political work. So if there's anything you want to develop a project, you would like to cooperate, you would like to know anything or whatever, talk to us or contact us online. This is our contact, and This is it from my side, thank you.
There's one thing which I think we missed out to mention, is that the idea of pretty easy is now we were focusing very much on the user's perspective, making the use of cryptography very easy. But the PEP concept also, which we haven't gone into the how it works technology-wise at all, but it is also pretty easy for a developer to plug PEP into their app. So if a developer has whatever, an SMS app on Android, they can just use the PEP engine and plug it in. And that's also why the licenses, the models are very open, so that the developer of the app is still the owner of the app, can use PEP and just enhance it with encryption. And just like plug and play, I wouldn't say, because we don't have proper documentation yet. But yeah, so that's the main idea as well. That's when Nana said, if you want to collaborate, I think that's a very important thing. So if you know anyone who wanted to have encryption in his app or whatever programming code he or she was writing, and then was like giving up on it, because, oh my God, this is like way too complicated, then you can point that person on PEP and maybe implement it there. So yeah, now you had a question.
Yeah, thank you. I don't understand how much PEP depends on GNU-net, or how much PEP is just about PGP.
Yeah,
At the moment, so the question was how much PEP does depend on GNU-net, or how much PEP is just PGP? Did
Yes.
Yeah. So at the moment we do not depend on GNU-net at all. PEP is just an email encryption app. There are different releases all going into the direction of being email encryption apps. This is what we're starting with. One of our middle-term goals is to implement GNU-net in PEP, which means that we would be able to, on top of the GNU PG, like the PGP encryption, we would then be able to also protect metadata, but this is in its starting phase already. So far, it's in its starting phase. So the first thing we need to check is if the GNU-net code is able to deal with really many users. So we first, as I said, and this is the particular project we will start in this year, do an emulation for the GNU-net code to test if it's able to scale. If the GNU-net code is able to handle this many users, then the next step will be to just to start implementing it into PEP. And then it's a combination. Then we will use both technologies. So far, it's only the PGP encryption.
Just to add one thing, and then so it's not depending on each other at all. Just PEP is one application for GNU-net, so it's great for GNU-net to have. And we're going for mass encryption, but we also hope to go for mass anonymization, which we can only do with GNU-net. Okay.
So if now is the email application, how is doing? Is it working? Is already in a stable release?
There's an Outlook plugin, because as Nana was saying, like there's also a company who's actually selling it to other companies. So Outlook is still the most common used email tool. And there's an Android client, which does...
It's an Android and K9 beta version.
And there's Thunderbird already, let's say, working on various systems, but we haven't released it yet.
As I said, there are several releases that are about to be finished. Thunderbird Enigmail is about to come. The KeySync is about to come. There is a whole developer team working on an iOS app.
It's actually pretty crazy because we are working on all those platforms at the same time, so it's pretty difficult to come up with something.
But concrete work is done. Many people work on that constantly, and watch out for releases.
Yeah, and the Outlook thing is in production.
Yeah.
It's already sold to like a particular amount of companies.
You should check our Twitter account, because just recently there were tweets about the recent state of the different solutions and releases. So it's all in detail there, and it can be found on the website.
And also to highlight this again, so at the moment it's email encryption tools, but that's only now a proof of concept. The idea is that now if you have, for example, this PEP for Android installed on your Android, and then we're going further with the development, then it doesn't only know GPG, it also knows about OTR. And then it doesn't only know about SMTP for email, but it also knows about XMPP. So then suddenly you can talk XMPP with OTR to someone else with the very same app. And yeah, that's the basic idea of having those like hacker decisions been taken by software. All right. Any more urgent questions? Otherwise, we're going to be around today. And we have lots of stickers.
Yeah, we have lots of stickers.
My friend is that guy who also prints them, those huge amounts for a Congress.
Also, you find like a longer, lengthy text about the PEP Foundation if you're interested. In other ways, just find us.
Hello, I'm Walter. I'd like to go in the last 15 minutes for the lower hanging fruits even. Basically what I want to try to do is a little bit of an interactive mapping session on what people in this audience would recommend their, let's say, non-techie, non-activist friends and family to use in their daily lives. Just to get an idea of what's out there, as far as we don't already have that idea, and also to, I hope, to incite some people to fill in the gaps that are undoubtedly there. This is punishment for using Acrobat. Brilliant. So the idea is basically what are we looking for? Not so much about state at state actors, because if your state actor is looking is going for you, you're just boned anyway. Then you better just stop using anything with a microprocessor in it. But mostly to raise the cost of for the surveillance economy players like Facebook, Google, etc. And these are more or less the constraints. What do the typical Windows or macOS or Android or iOS users and do accept the fact that they will be permanently logged into Facebook? So, let's say, Mike, what would you suggest as a plugin to, let's say, a non-technical member of your family?
What sort of plugin?
As in, what would be the lowest hanging fruit to help people to stop being Tor? Who else would advise that? Can I have a show of hands?
Privacy Badger.
4 or 5 people out of this group would say Tor. So this may be slightly less low-hanging fruit than... you were going to give another suggestion.
Privacy Badger.
Privacy Badger. Yeah. That was one I would have done myself, but yeah. Any other votes for Privacy Badger? That looks like at least a large group. Can't read it from there, but it's just for my own documentation afterwards.
HTTPS everywhere.
HTTPS everywhere. Yeah, would get my vote as well. But that's all web. What would you use for mail?
Web.
Say again?
And
For Gmail. PGP for Gmail.
PGP for Gmail.
I would say don't use mail.
Stop using mail. I think the under 24 will be with you. So now you were saying use another mail provider, like? You were suggesting another mail provider.
Yeah, using another mail provider, like Mailbox or Posteo, Systemd, Reza, like any of those who like tell you that they're actually taking care of your privacy.
Yeah, no, go ahead.
Like an offline client, like Thunderbird, for example, to avoid being logged in inside your browser all the time. Very easy to see.
Yeah, but then it sucks that your mail is never synchronized across your devices, which is great about webmail. I mean, I use Thunderbird myself, but only on one computer, because it's an incredible pain to set it up in a way that you actually have your mailboxes in sync across different computers.
That's true, yeah.
And although I know a stupid lawyer, I used to be a programmer in a long time ago in a faraway galaxy, so I'm not entirely non-technical. But yeah, I'll put down as an option, local mail client. So you can enjoy the user experience of Enigmail for various variables of enjoyment.
I'd suggest install the desktop clients for WhatsApp and Signal, because if the threat model of PGP mail is to people who know sending personal communications, and if you're trying to maximize the highest chance that the person on the other side will have access to the encrypted protocol, then I think the desktop client might move people to sending longer form messages, and then they have to worry about keys.
I write down the Signal desktop client because WhatsApp is evil and should be forbidden and not open source. But taking at least half of your suggestion. That's sorry for being such an asshole about that. What I'm wondering about is, and that's a bit of a mean question, is I see an awful lot of usage of URL shorteners. What would be an alternative to that? Because every time you use a URL shortener, the shortener service basically gets handed over a lot of your browser information for free. It's a new gatekeeper. Does anyone have a solution to the problem of the URL shorteners? Sven?
I mean, using own URL shorteners. I mean,
Roll your own URL shortener, Ramon. Yeah.
I know that's not like a very common solution.
Actually, it's much easier to build than people think, but I would not say.
I think the problem with the URL shortener is mitigated by privacy badger automatically.
By what?
By privacy badger is a web domain that installing to you or script or cookies, but privacy badger can identify that as a harmful domain.
So you're suggesting the privacy badger already solves your URL shortener problem?
Actually, it limits, as far as I know.
Okay. I actually wouldn't know, wouldn't be able to judge. I would expect the shortener service to still be able to see the refer URL and where you're coming from, etc., regardless of privacy badger. But
I know it's true. Those are things that the shortener is C.
yeah,
The shortener is C. You refer some of
Yeah.
your navigation information and the extension URL, but the privacy badger limits the information, the kind of script they can execute and cookies they can install.
yeah, fair enough. I'm still going to write down roll your own URL shortener, although it's not going to get many votes, I'm afraid.
And you use QR codes? QR codes.
But,
You can't use them yourself for the simple low-hanging fruit. There might be QR codes instead of the URL shortened URL. You can send as a picture.
I may be missing something here.
So something you want to post?
Well, I was, for example, you're sharing a URL on social media, and that's the point where people automatically use lots of shorteners. And that results in fairly easy patterns for the URL shortener service to follow. That's
Shorten your message.
Surely your threat model is not people using URL shorteners, but people clicking on shortened URLs. Is that not more of a threat model? So in the average user, I don't think URL shorteners, the people you're talking about, low-hanging fruit, I'm not sure people are often actively using URL shorteners. They're often getting a URL shortened automatically.
yeah. I would already love to have a browser extension that will recognize URL shorteners and look it up in a different way to circumvent them.
I think Privacy Badger does that for stuff like Twitter and stuff.
Okay,
Yeah, and Raster.
then I have to look again at Privacy Badge again.
I know about one called is.gb. Very hard to remember. I need to look it up every time I need to shorten it.
And they are a privacy-friendly shortener?
An ethical one.
An ethical one.
I'm not sure if privacy.
How can you be ethical without looking after privacy?
Hopefully they're not looking into the data.
is.gb or GP?
GD.
GD.
Is good.
Say again?
Is good.
Oh, yeah, it's good. Yeah. I'm getting the joke now, yeah. I'm a bit slow. I only had one coffee. It was Belgian coffee. Doesn't count.
Use services from Microsoft. They have, I think they have URL shortener, they have images hosting, Framadoc instead of Google.
What was the name of the host?
Framasoft.
Framasoft, okay. Anything else? How are we doing time-wise, Guillermo?
15 minutes, 10 minutes.
We have still 10 minutes.
You could consider using a VPN client that syncs known endpoints of trackers on your mobile phone. An example is disconnect.me. That will save you from a lot of tracking also outside of your apps. Disadvantage is that some apps may be a bit slower because you have to wait.
Yeah. And how much is a bit slow?
Maybe it could take a few more seconds for some content to pop up.
Because that's the other bit that I had made a slide about, but given the problems I had with the projector, I didn't display it. The mobile sphere is, I think, even harder because there's so much crap on everyone's mobile phone, or most people's mobile phone. Say again?
Well, therefore, I think. I think you should, as a simple measurement, you should keep everything off your mobile phone. If it's not privacy enhancing, or if you really want it.
That's a school of thought that may work for you, but good luck telling a 16 or 17-year-old you can't do anything on your mobile that's really interesting. That's where the social life is. Not everyone wants to be a hermit, basically.
Well,
Say again?
yeah, you're right with it. So most of the measurements you have on the blackboard now are for enhancing privacy. So what we don't have right now is, let's say, leveraging privacy. And I would suggest that if somebody has a special interest, he should install an app, configure that app for this special interest. Okay, it's his business, but not do it widespread. And okay, if you are collecting lots of stuff on your mobile phone or on your other devices, you just have so many different intentions and have so many different thoughts that you will have to accept a lower level of privacy in the end, I suppose, for getting the convenience.
Maybe it's a religious thing, but I don't want to believe that. I mean, there was a time when our devices were ours and the data that stayed there and was that was our stuff basically.
Yeah.
And at some point we have, because the vast majority of us didn't realize it, we made it a looking glass for other interests. I don't really care whether they're corporate or state or not. It's not me.
Well,
And-
I think the point is that we pay with personal data for some services. And it's just established in some part of society, I think even those younger or those older just do not care and they accept paying with their personal income.
There's a lot of research going on globally, both in the United States and in Asia and in Europe. And across all those cultures, as soon as people get told how much of their data is being collected, they're not comfortable with that in the slightest. The post-privacy argument, well, you're selling your data, and it also falls flat in the face of the fact that if someone communicates with me, for example, I don't have a Facebook profile, at least not a normal one, but I do have a shadow profile because my phone number is in other people's phone directories and has been scooped up by Facebook app. And then you can say, well, you chose to opt out from Facebook. No, despite me choosing to opt out from Facebook, I still got opted in against my wishes. And my data has been sold by someone else as a currency for their love of being on Facebook. So I'm not really buying that argument. As in, oh yeah, we have been doing this now for such a long time, therefore we should stay on doing it. It's like saying, oh, asbestos is such a cool material, we should keep using it. It has fantastic properties. You only get cancer of it, but that's just in the far future. I don't care.
Well, I think the main problem is that something has to be established which is better. And even in the preceding talk, I heard so much about a lower level which we can build applications on, but I think we need the killer applications, including privacy, solving the privacy problems, which can be widespread and be used and be attractive. And then we can enhance privacy in a really cool way, but but I think otherwise we won't get that far.
Oh, I do agree. It must be beautiful and usable and nice and all that. That's why I'm looking for simple things like browser extensions and just apps people can install, because then you can easily run this mini privacy cafe for yourself and among your circle of friends. But we've been discussing too long already. I think you were waving your hand.
I advise to use websites when possible instead of applications, because as we've seen, you can install add-ons on web browser. But there's usually a lot of traffic trackers inside smartphone applications. So use the website instead of the application.
Mobile phones, particularly.
Yes.
With 400 web traffic.
Okay, so as a general advice, you would say use the web versions of whatever online service you use instead of the mobile app, because the mobile app will just use much more.
There's one other comment I want to make based on that discussion. So basically, with the tools, you're starting to make the issue invisible to the ordinary people, which takes the pain away. I think we first should have tools that make the problem visible. So things like Privacy Badger that can show what trackers you have just missed out on. So Ghostery can do that. An app like Lumen, which on Android phones will put in your face how many tracker plugins are in the app you use on a daily basis. You'd be surprised how often Facebook is called by your email app. That while you're not even a Facebook user, you don't even realize it's there.
I put on Lightbeam as an extension.
Yeah, fine. But make it visible first, because otherwise there is no incentive. And then I think the key question is, do you want to make the problem go away by masking it, because that's what this is about, or do you want to fundamentally change it? And then the question I would have also to the audience is, would you accept the problem to be reduced to such a level that it becomes bearable, and that's what these tools do? Or do you want to re-engineer properly from the start with privacy in mind? Which is basically what you're doing. So the risk of doing this is that you make the real problem, or maybe even invisible and bearable, rather than structurally fixing the internet.
I think that's a very interesting point. At the same time, what I love about, for example, the privacy cafes and the crypto parties is it gives people a sense of agency. People tend not to bother about problems. They have a feeling they can't do anything about it. And if they can do a little thing in their own life, that already is an empowering action. There's at least two hands in the back.
Yeah, I also agree with that. This obviously, would be much better, but like re-engineering everything from the start is hardly a low-hanging fruit, and it's nothing that normal users are capable of doing. And also, I think to the things that have been said before, we should not fall into the trap to think that privacy and non-privacy is a binary thing. It's not like I have privacy or I don't have privacy. That's not how it works. It's a gradual, think of it like a shifter. And the more you can shift it towards privacy, the better it is. And even if it's just a little bit, and it's always worth it. It's not binary.
Also, better is the enemy of good.
Yes.
Behind you.
I think in relation to those last 2 points, we focus a lot on the online world, but there's a lot of offline tracking as well, such as loyalty cards and so on. And especially from May, one of the most powerful things I think you can do to encourage organizations to re-engineer is to make subject access requests and to tell normal people to do it, which they almost never have in the past. And many of these organizations, shops, and even tracking organizations are actually just not used to responding to subject access requests from normal people. And getting a lot of those does force organizations to think about how they re-engineer things in the future, questions that may not always come up. So these aren't always big bad actors. Sometimes they're just actors that have never been pushed to think about it.
Bits of Freedom has a subject access request letter generator for the Netherlands. How many other member states do have similar websites that you can just type in your name and you get a, I'm sorry.
There are databases in the UK, but it's a bit tough. It's not decentralized. It'll be easier when they're electronic. Still in the UK, a lot of data controllers only will accept physical letters.
Oh, but the beauty of that letter generator is it just generates a PDF for you to print out. And
that's good. Yeah, great.
also, bear in mind that processing a letter is easily costing tens of euros for the recipient.
Well, usually costs 10 euros for yourself at the same time.
Yeah, but it's so much nicer than dialing a phone number and having to listen to music and all that. That's so much more of a pain for them.
It's often been closed £10 in the UK to do it, otherwise they won't process it.
Yeah, that's going to change.
Yeah, I would like to add something because I know that if you want to re-engineer everything from the start, privacy very, very, very quickly becomes a problem that is not only related to privacy as such, but it's related to how our society works, how capitalism works, because they do it for control and they do it for money, same as they try to evade taxes and everything. So, of course, this is a high-hanging fruit. You can choose to be political, you can choose to try to do something on either side of the thing. You can also engage in environmental work or whatever. But if you want to break it down to what you can do in terms of low-hanging fruit, you can also say choose a job, choose an ethical job. I don't know, engage in activities that include privacy in their ethical structure. Try to support those projects and the like to just spread the infrastructure for more things to evolve and emerge that try to solve those deeper layers of the thing.
I'm not going to reply to that. A last question to the group. What would you do about Wi-Fi tracking in public spaces?
Not using.
I'm sure you have a Samsung phone.
Say again?
If you have a Samsung phone, that randomization almost never works.
Yeah, I've seen apps that will turn off your Wi-Fi as soon as you're from in an unfamiliar location.
Yeah, Mac randomization is quite a good defense in most cases. So Apple phones, for example, and some Androids will automatically randomize Mac addresses, but Samsung phones don't. So with Android, it's a lot more hit and miss depending on the hardware.
So it's very fundamentally broken by design in the case of Samsung. Good to know that. Don't buy a Samsung phone.
Well, if you can afford it.
They're actually not that cheap.
The Mac randomization is indeed breaks Wi-Fi technology.
For now.
It depends on the parameter.
Yeah, there are some re-identification attacks that you tag someone for about 20 minutes maximum based on other fingerprinting on the device.
That's enough for a lot of public spaces.
Again, you can make an access
And I think it's about time. So I'd like to thank you for bearing with me with this entirely unstructured, vague thing. So thank you.